Hello everyone and welcome to this interesting video on IPL data analysis by Simplilearn. Indian Premier League, that is IPL, is one of the most popular and exciting events in world cricket. IPL 2022 will begin on 26th of March, so it's the best time for us and our viewers to learn about how to perform exploratory data analysis using the recently held IPL auction dataset. So in this video, all the results and insights that you will see are totally based on the data we have collected from Kaggle. We will leave a link to the dataset in the description of the video. You can go ahead and download it. For this demo, we'll be using Python and Jupyter Notebook to answer specific questions. So let's get started. We'll move over to our Jupyter Notebook. Okay, so I'm on my Jupyter Notebook and this is the file that we are going to use. So here you can see I have some of the cells already filled in. So this will save us some time and we can explore this data set in depth. So this is the file that I'll be using, or the IPython notebook. Cool. So first let's go ahead and import all the crucial libraries that will be needed for our analysis. So here you can see I am importing the pandas library, the numpy library. These are for data manipulation and numerical computation. Then we have seaborn and matplotlib for data visualization. Then I have imported this warnings module so that we do not get any warnings while running the code. Cool. So let me just hit Shift Enter to run the first cell. So here we will import all the libraries. Okay, it's done. Now the next step is I'm going to create a data frame in the name of IPL, and here I'm importing the dataset using the read_csv function, which is part of the pandas library. So PD here has been imported as pandas. I am giving the dataset location followed by the name of the dataset. So here the name is IPL_2022_dataset.csv is the extension of the file. So let me go ahead and run this as well. Alright, so now we have successfully imported or loaded our dataset. Now the next step, let's go ahead and explore our dataset. So I'll use the head function for this, IPL.head. Okay, so here you can see the different columns. We have an unnamed column which is actually unnecessary for our analysis, so we'll see how to drop this column. Apart from that, we have the name of the players, the base price at which the player was sold, or whether the player was a draft pick. So here Rashid Khan from Afghanistan, Hardik Pandya, then we have Subman Gill. These are all draft pick, and then we have the price at which the players were listed in the IPL auction. Then we have the type of player, whether the player is a bowler, an all-rounder, a batsman, or a wicketkeeper. Then we have the cost in rupees. This is in crores. So basically this column tells us the price at which the player was sold in the auction. Then we have the price or the cost in dollars. After that we have 2021 squad. Basically this means in last year's IPL, where was the player? So here you can see Rashid Khan was playing for SRH, the Sunrisers Hyderabad, in 2021. But this year in 2022, he'll be playing for Gujarat Titans. Similarly, Hardik Pandya was playing for Mumbai Indians for past few seasons, including 2021. But this season is going to play for Gujarat Titans. So on and so forth. Now, let's see the total number of players that are present in the dataset and the total columns that are there. For this, I'm going to use the shape attribute. So I'll write IPL.shape. You can see here there are total 633 players that were part of the auction, and this includes the players who were draft pick also. And there are total 8 columns in my data frame IPL. Next, let's use the info function to check the columns, the data types, and the total non-null objects. So I'll say IPL.info, which is a function, so I have to use brackets. There you go. So here you can see it says total 633 entries from 0 to 632. Data columns, we have total 8 columns, and then these are the different column names, and here you can see the total non-null objects present in the column, and here you can see the data types, and at the bottom you can see the memory usage as well. Cool. Now the dot columns attribute will return the name of the columns in the data set. So if I say ipl.columns and run it, it will give me all the different column names that are present in the data frame. Now as I said, the first column, which is unnamed :0, is actually unnecessary, so we are going to drop it. For that, we are going to use the dot drop function, and then I have passed in my column name followed by the axis, on which axis is it there, and then I say in place equal to true, which means it will replace and permanently remove the unnamed column from the data frame. So let's run it, and now we'll again check the head of the data frame. You can see before we had the unnamed column, which was the first column in the data frame, and now we have successfully removed it, so player becomes the first column in the data frame. Alright, now moving ahead, let's see the total number of null values that are present in each column of the dataset. So I'll say IPL dot, I'm going to use the isNull function followed by the sum function. If I run this, you can see here the player column doesn't have any null values. Similarly, base price and type column also don't have any null values, but you can see cost in rupees and cost in dollars have nearly 396 missing or null values. The reason being, those players were not picked in the IPL auction, and hence there was no price associated. And then you can see there were a few players who were not part of the IPL squad in 2021, so those are being reflected as null as well. Now we'll check the rows that have cost in dollar as null or NaN. So here I have used IPL, and after that I'm passing in the column name, which is cost in dollars, and then I've used the isNull function. If I run this, you can notice the cost in dollars column, all these values are NaN or null, and even the same rows have NaN for cost in rupees as well. Cool. Now the next task is to fill these null values or NaN values with zeros. So for that, I'm going to use the fill NA function, and here I have passed in 0. So all the null values in the dataset will be replaced with 0 for cost in rupees column and cost in dollars column. Let me just run it. Alright. Okay. Now we will see the players who were unsold in the 2021 auction, which means we will check the rows that have null values for the 2021 squad column. So what I'll do is I'll say IPL, within square brackets I'll say IPL, and then I'll pass in my column name, which is 2021 squad, and then after this I'll say dot is null. So this cell will give us the unsold players in the 2021 auction. If I run this, you see here, you mark the 2021 squad column, all these players were unsold or did not participate, so hence it has NaN values. Alright. Now what we are going to do is we will replace all the null values that are present in the 2021 squad column with not participated. Like how we did in the previous example, we replaced all the null values with 0. Here we'll replace with a text value called not participated. So I'll say IPL, I'll pass in my column name, which is 2021 squad, equal to, I'll say IPL 2021 squad dot fill NA, which is the function, and here I'll pass in a text or a string saying not participated. Alright, let's run it. Before that, let me just scroll it down. Now I'll run it. Cool. Now that we have treated the null value successfully, let's verify it again. So I'll just say IPL dot is null, and then I'm going to use the sum function. If I run this, okay, this is also a function. Cool. Now if you see, we have successfully removed all the null values and replaced with either zeros or not participated, and hence now you can see none of the columns in the IPL data frame have null value, so it shows 0. Great. Now moving ahead, now we are going to add another column called status, which will hold two values, sold and unsold. But before that, we are going to slice our data frame. So here I am looking for all the rows where cost in rupees is greater than 0, and those should be unique, and I'm storing the value in a variable called teams. So here you can see we have the different teams where the cost in rupees is greater than 0. Now I'm going to create another column called status. So I have written IPL within square brackets. I'm passing in the column name, which is status, and that will be equal to the team replaced by sold value. Let me just run it and show you the result. There you go. So here you can see we have added a new column called status, and it has values sold and unsold. If I just say IPL, at the bottom you can see the unsold values as well. Cool. Now in the next cell, we are going to check for duplicated players. So there are duplicate rows in the data frame, but here the names of the players are same, but in reality the players are different. So it is quite understood that different players can have the same name. So to get those names, I am using the duplicated function, and I'll say keep equal to false, which means I don't want to keep those players. Now let's run it. There you go. So here you can see Lalit Yadav, we have two entries. So Lalit Yadav here is an all-rounder whose base price was 20 lakh for 2022 IPL, and last year he was playing for the Delhi Capitals, and this year also he is sold to Delhi Capitals. Next we have Lalit Yadav, who happens to be a bowler. So this is again different Lalit Yadav. So last year he was unsold, and even this year he remains unsold. Similarly, we have Amit Mishra, who earlier used to play with the Delhi Capitals, but this time he remains unsold, so on and so forth. So you can see two entries for Subham Singh as well and Shivam Mishra. Alright. Now let's answer a very basic question. We're going to find out how many players have participated in the 2022 IPL auction. For that, we have already seen the total number of rows that were present, but again I'm going to use the shape function, and within square brackets I'm going to say 0, which means it will give me the total number of rows, and you can see 633 players were part of the auction. This is as per our data that we have collected from Kaggle. Up next, we are going to find how many types of players have participated. So I'm going to say types equal to, say IPL, I'll use the column name which is type, and I'm going to find the count of each type of players that are present in the data frame. I'm going to use the values underscore counts function, and then I'll say types dot reset underscore index. If I run it, okay, there is an error here. Let me debug the error. Okay, so this should be value underscore counts, and the variable name is types and not type. So let's run it. You can see here we have the different types of players. So all-rounders, there are total 242 all-rounders who are part of the auction. Then we have 215 bowlers, 112 batsmen, and 64 wicket keepers. Now using the above table that we just created, I'm going to plot my first pie chart. So for that I'm going to use the matplotlib pie function. So plt.pie, I'm using types.values since I want only the values from this table, and then I'm saying labels equal to types.index. I've used a label distance of 1.2 to maintain some space, and then this is my format in which I want to print or show or display the percentage of distribution. I'm going to use shadow, so it says shadow equal to true, which is another parameter or an argument, and then I'm going to start my angle at 60 degrees, and here I have used a title called roll of players participated that will have a font size of 15, and finally I'm saying plt.plot. So let me just run it. There you go. So here we have a nice pie chart or a pie plot. So you can see the different pies here. We have all-rounder, wicketkeeper, batter and bowler. So majorly there are all-rounders in the auction, followed by bowlers. Then we have 17.69% batters and 10.11% wicketkeepers, which is the lowest. Cool. Now we are going to create another bar plot or a bar graph that will tell us how many players were sold and unsold. So for this I'm going to use a count plot. So we'll create two bars, one for sold and the other one for unsold, and each of the bars will have different colors. One will have orange, the other one will have pink, and I'm using labels. So to label the x-axis and y-axis, I have sold or unsold. Y label will have number of players. The title of my bar graph would be sold versus unsold. I've given a font size of 15 and I'm saying plt.plot. Now the function that you see here at the bottom will display the data labels for each of the bars. Let me just run it and show you the result. There you go. So I have used a figure size of 10,5. Alright, now you can see we have a really good bar plot which says there were total 237 players sold and 396 players were unsold as per the data we have. Cool. Now you can also print the total sold and unsold values. Let me show you how to do it. I'll say IPL dot, we can use the group by function, and I want to group it by status column, and the value that I want to measure is the players count. So I'll say players, rather player, and then I'm going to use the count function. If I run this, you can see here I've successfully grouped the unsold and sold players. The values are matching with the bar plot that we just created. So sold were 237 players and unsold are 396. Cool. Now we are going to see the total number of players bought by each team. Again, this is going to be a count plot, so basically a bar plot. So here the condition I'm passing is in the teams column the value shouldn't be unsold. So players bought means the value should be sold. So here I'm using this condition, and the rest of the things remains the same. One improvement I have done here is I'm using xtext rotation equal to 70 degrees. This basically means the x labels would be tilted by 70 degrees. Now let's see the bar plot. There you go. So here you can see I have the title players bought by each team. On the y-axis we have the number of players, and on the x-axis you can see the values have been tilted by 70 degrees. Let me just zoom in so that you can see it better. And this is the bar plot. So the maximum a team can purchase is 25 players. Some of the teams have also purchased 24, 22 and 23 players. Let me just show you. So Gujarat Titans have totally purchased 22 players. Then Delhi Capitals have total 24 players in their squad. Again, Lucknow Super Giants have 22 players. If I scroll and see again, Bangalore Royal Challengers or RCB, the Royal Challengers Bangalore have 22 players in the team, and Rajasthan Royals and Sunrisers Hyderabad have 24 and 23 players respectively in their teams. Alright, now we will create 3 more columns called retention, base price and base price unit. For that, first of all, I am creating a new column called retention, which is equal to IPL base price. Let me just run it, and then I'm going to replace these values that are present in the list: 2 crore, 40 lakh, 20 lakh, 1 crore, 30 lakh, 1.5 crore with from auction, and I'm saying in place equal to true. Let me just run it. Then we are going to treat the base price. So here in the base price column, I'm going to replace draft pick value as 0. So let's run that as well. And now I'm going to split the base price value into two separate values called base price unit and base price. So basically I'm splitting on the space that I have. Let me show you how it is going to split. So this is, let's say, our base price column. What I did was I replaced the draft pick values to 0, and then the rest of the values will be split into two columns called base price unit. So basically it will have the unit of the base price, let's say crores or lakhs, and the base underscore price column will have the value, which is 2, here 40, 20, 20, so on and so forth. Let me just scroll down and run that particular cell. Now to create these two columns, the base price unit column and the base underscore price column, I have used the lambda function and I'm splitting based on the space. Let's just run it. Now I have replaced retained with 0, and let me show you the final data frame that I have. So here you can see we have replaced the draft pick values in the base price column to 0, and on the right side you can see the three different columns that I wanted to create. So one is called retention. So zeros refer to draft pick. Any other value will say the player was picked from the auction. Then you have the base price unit. So here you can see crores, lakhs, and the value base price is 2, 40, so on and so forth. Cool.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's check how many players were retained and bought from the auction by each of the teams. So I'll say IPL, let me just scroll down, dot, I'm going to use the group by function, then I'll say team, comma, retention, then I'm going to use the value as retention because I want to find the count of retained players. And then I'll say colon -1. Let me run it. You can see here the different team names because I have grouped by team and then retention. So I have Chennai Super Kings. From the auction they had picked 21 players and they had retained 4 players. Coming to Delhi Capitals. Delhi Capitals in the 2022 IPL auction they picked total 20 players and they have retained 4. Similarly, if I scroll down, let me talk about, let's say, Punjab Kings. They have picked 23 players from the auction and retained 2 players from the team last year. Talking about RCB or Royal Challengers Bangalore, they have picked 19 players from the auction and they have retained 3 players. Alright. Now in the next cell of code, we are going to display the players in each team based on the different types of players. So let me just run it and show you the result. So here I am using the same condition. The value shouldn't be equal to unsold, and I'm going to use another parameter called hue for the different colors. So here I have used hue as type because I want to show the players in each team based on the different types. Again, I have given my title to the bar plot, and then I have the X label, the Y label, and my rotation is 50 degrees now. If I scroll down, you can see the different types of players. Here is the legend. So blue is for bowler, orange or yellow is for all-rounder, green is for batter, and red, which also looks like maroon, is for wicket keepers. And on the x-axis you can see the different team names. Alright, now let's answer another couple of questions. So here I have, what is the highest amount spent on a single player by each team? So to solve this question, I'll say my data frame name, that is IPL. Then I'm going to say retention equal to this should be from auction because we want to see the highest amount spent and not from the retained players. Then I'm going to group by, I'll say team, and then I'll say cost in, let me just copy it from here, cost in rupees, that is in crores, and I'll say max colon -1 dot sort underscore values, I'll say ascending equal to false, which means I want the sorted result in descending order. Okay, let me just bring this to the left side and we'll run it. There seems to be some error. Let me check the error. It says there's a spelling mistake. This should be team. Let me run it again. There you go. So you can see Mumbai Indians have spent 15.25 crores for one of the players, and this player happens to be Ishan Kishan. Then Chennai Super Kings have spent the highest amount for a player who happens to be a bowler. The name is Deepak Chahar. They have bought him for 14 crores. Kolkata Knight Riders bought Shreyas Iyer for 12.25 crores, and so on and so forth. So these are the highest amounts spent on a single player by each of the teams. Let me scroll down. Now we are going to see the player retained at maximum value or maximum price. Now if you follow IPL, the maximum price at which a player was retained happens to be Ravindra Jadeja. So let's see at what price was he retained. I'll say retention equal to I'll say retained, then I'll say sort underscore values by equal to, I'll use the same column, cost in rupees, that's in crores. I'll say ascending equal to false dot head, and I want to find the top player. Again there's some error. Let's see where is the error. Says ascending equal to false dot head. Okay, this should be sort underscore values, within bracket I should say by. I think this should be fine now. Let's run it. There you go. So you can see here our result is player name Ravindra Jadeja, who was retained for 16 crores by Chennai Super Kings. Cool. Now the next cell of code will display or print the top 5 bowlers who have been picked in this year's IPL based on their cost in INR. Let me just run it and show you the result. You can see here Deepak Chahar went for 14 crores. Then we have Shardul Thakur, who was bought by Delhi Capitals. Earlier he was part of CSK for 10.75 crores. Then we have Prasidha Krishna, who has been bought by Rajasthan Royals this time. Last year he was with KKR and he has been bought for 10 crores. Similarly, Lockie Ferguson has been bought by Gujarat Titans and he played for KKR last season. He has been bought for 10 crores while his base price was 2 crores. Then we have Avesh Khan. You can see Avesh Khan's base price was just 20 lakhs and he has been bought for 10 crores by Lucknow Super Giants again, and last year he was part of the Delhi Capitals. Now you can replace this value. Suppose let's say you want to find the top 5 batsmen picked or batters picked with the highest amount. You can just say batter instead of bowler, and if I run this, you can see here Shreyas Iyer was bought by Kolkata Knight Riders for 12.25 crores. Last year he was part of Delhi Capitals. Then you have Shimron Hetmeyer, who's from West Indies. He has been picked by the Rajasthan Royals for 8.5 crores. Then we have Rahul Tripathi, Shikha Dhawan and Devdutt Padikkal. Now if you wanted to check for, let's say, all-rounders, you can replace batter with all-rounder. If I run this, you can see Liam Livingstone has been bought by Punjab Kings this season for 11.5 crores. His base price was just 1 crore and last year he was part of the Rajasthan Royals. Then we have a player from Sri Lanka, Hasaranga. Then we have Harshal Patel, Shah Rukh Khan and Rahul Tewatia, who have been the top 5 all-rounders picked at highest amount. Cool. Now finally, we want to see the players who were part of the IPL last season but were not picked for this year's IPL. So for that, what I'm doing is, first I'm renaming my 2021 squad column. This column I want to rename it as previous team. Let's run it. Then I'm going to find out the unsold players. So here I'm saying previous team not equal to not participated, and then I'm using another condition. The team should be equal to unsold, and I'm going to find out only the player and the previous team. So let's run it and see the result. So here you can see These players were part of the IPL last season, but they haven't been picked this season. And last season they had played for, let's say Suresh Raina played for CSK, Steve Smith was part of the Delhi Capitals, Sakib Al Hasan was part of KKR. If I scroll down, you have David Malan, who played for Punjab Kings in 2021. Owen Morgan, who played for KKR. He also captained KKR, but unfortunately he was not picked this season. Chris Lynn from Australia also remained unsold this season. Andrew Tai, we have Ben Cutting, Aditya Tare. There are other players as well. We have Kane Richardson, Dhaval Kulkarni. Cool. So these were the players who were part of the IPL season 2021, but unfortunately were not picked and remained unsold for 2022 season. Cool. And that brings us to our end of this demo session on IPL data analysis 2022. So we learned how to use the different functions and attributes that are part of the Python libraries, and we manipulated the data, we visualized the data and answered some specific questions. Formula One, also known as F1, is a motorsport defined by open-wheeled single-seat race cars. It features the best drivers in the most powerful and technically advanced cars. The sport is governed by the FIA, that is International Automobile Federation. Here 10 teams comprising of 2 drivers each compete in a series of races over a period of 1 year to find out the ultimate driver and a constructor champion. In our demonstration, we'll be using 4 datasets. Let me show them one by one. These are all CSV files. Now this is the first dataset that we'll be using in our demo. So if you notice, the dataset does not have column names. In fact, none of the datasets have column names. So while importing the dataset, we'll assign the column names using the names parameter. I'll show that in a while. Now this is the results dataset. The results dataset has information about the result ID. Then we have the race ID, driver ID. We have the constructor ID, grid, position. Then we also have information about the fastest lap. Then we also have information about rank, the fastest lap speed, and the status ID. Now moving on to the second dataset, which is about races. Now this is the second dataset, which is about races. So it has information about the race ID, the year in which the race was held. Then we have the round number, circuit ID, then the name of the Grand Prix. So you can see here Australian, Malaysian, Chinese, Spanish, Monaco, Turkish, British, German, and others. Then we have the date on which the GP was held or the Grand Prix was held. We have the time and a URL which basically leads to the Wikipedia page of that particular Grand Prix for that year. Now moving on to our third dataset. So this is our third dataset, which is about drivers. Now it has the driver ID, the name of the driver. You can see here Hamilton, Rosberg, Alonso, Raikkonen. Then we have Sato, Massa, Button, Weber, and all. After that, we have the number code. Then we have the forename of the driver, the surname of the driver, and then we have the date of birth of that particular driver. We have the nationality as well. And we have the Wikipedia page for the driver. Now moving on to the last dataset, which is about constructors. So this is the fourth and the final dataset that we'll be using in our data analysis project. So here we have the constructor ID, then the constructor reference in Formula One, and this is the actual name of the constructor. So we have McLaren, we have BMW Sauber, Williams, then we have Ferrari, Toyota, Red Bull, Force India. We also have Jordan, Jaguar, and all. Next, we have the nationality and the URL, that is the Wikipedia page of that particular constructor. Now let's head over to our Jupyter notebook and we'll start with our analysis. Here is my Jupyter notebook that I'll be using for this demo. You can see some of the cells are already filled. This is just to make sure we save some time. So using these datasets that we just saw and our libraries such as NumPy, Pandas, Matplotlib and Seaborn, we'll answer specific questions such as the drivers and constructors who have been the most successful throughout the history of F1 sport. Then we'll explore the impact of starting and finishing positions and if the speed of the cars has changed over the years. So let's begin with our analysis. First and foremost, we are going to import all the necessary libraries. So here I'm importing NumPy, Pandas, Matplotlib and Seaborn. And after that I'm writing percentage matplotlib inline. That is to ensure that all the plots are embedded inline. I'll hit Shift Enter to run it. It'll take some time. There you go. So we have successfully imported all the libraries. Now the next step is to load the data and assign column names. So I'll load my first data, which is results. I'll say pd dot read underscore csv. I'll give my file name, which is results dot csv. And then using the names parameter, I'll pass in the column names. So actually I have written the column names in a notepad. Let me open that. So I have this F1 notepad created which has the column names. I'll just start copying the column names. Within the names parameter, I'll paste it. If I scroll to the right, you can see the different column names that have been assigned. And for that, I'm going to say comma and I'll write header equal to none. I'll close the bracket. Cool. Similarly, let's import the second data set, which is about races. I'll say pd dot read underscore csv. I'll give my file name, which is races dot csv, and then I'll give the names parameter. This is actually names and not name. Okay. I'm going to copy the second line and I'll paste it here. And again, I'll say header equal to none. Next, we'll import our third data set, which is about drivers. So I'll say pd dot read underscore csv. I'll say drivers dot csv. And then again use the names parameter and I'll copy the third line now, which has the column names for the drivers dataset. Here I need to give another parameter, which is header equal to none. Finally, we are going to import our constructors dataset. We'll say constructors equal to pd dot read underscore csv, which is the function present in the pandas library. I'll say constructors.csv, which is my file name, and then again I'll use the names parameter. I'll go to my notepad and this time I'll copy the fourth line, which has the column names for the constructors dataset. I'll paste it and here I'll give my final parameter, that is header equal to none. Alright, now Let me hit Shift Enter to run it. Okay, we see some error here. Let's debug the error. It says no such file or directory, drivers.csv. Let's see where was the issue. Okay, this should be driver.csv. Cool. Now we have successfully loaded the data and assigned the columns to the various data sets. Now the next analysis is to merge all the data set. So here I'll create a data frame called df and I'll use pd.merge function. First I'll use the results data frame that we just imported above, this one, and I'm going to merge it with races data frame, and from the races data frame I'm going to take specific columns like the race ID, then I need the year, after that I need name. Next I'm going to take the round column as well, and I'm going to use on parameter. So on parameter is actually the column that is common to both the data frames, that is results and races. So here my common column is going to be the race ID because it is present in both the data sets, and I would like to merge. So for that I'm going to use how. So I'm going to use a left join. So if you know SQL, you will be aware of left join. It takes all the rows from the left table and only the matching rows from the right table. I'm again going to use the merge function. So I'll write df equal to pd dot merge. I'll say df comma, and now I'm going to merge the diverse data set, and I'm going to select specific columns. So I'll say driver ID. Make sure there are no spelling mistakes in the column names. Then I'll say driver ref, which is the name of the driver or reference, comma, and then I want the nationality of the driver. All right, I'll give a comma. I'll say on which column I want to merge. So here the common column is going to be the driver ID. Again, how is going to be a left join. Going to the final merge part, I'll say again df equal to pd dot merge. I'll pass in my data frame, and my final data set which I have is about constructors. From constructors we are going to choose specific columns. So I'll take the constructor ID, then I'll take the name column, and again the nationality column of the manufacturer. Here I'll say on equal to the common column I'll use is constructor ID. Give a comma and say how equal to left again. Cool. Make sure you're merging it with the right column names. So let's run this cell to merge all the 4 data sets. I'll hit Shift Enter. Oops, there is some error. Let's see. It says constructor ID index. Okay, there's a spelling mistake. This should be constructor ID. Cool. Let's run it. There you go. Now the next thing we want to do is to drop the unnecessary columns. So I'll say df dot drop. Within the drop function, we are going to pass in the column names. I'll say number. Then we also don't want the position column. Next we have position underscore text. After that we have laps. Next we are going to drop fastest lap. Then we'll also drop the status ID, comma. We'll drop the result underscore ID column. Then going to drop the race underscore ID column. We'll also drop driver underscore ID column. And finally we are going to drop the constructor underscore ID column, and I'll say access equal to 1, and in place I'll say equal to true because I want to remove it from my original data frame, that is df. There you go. Now the next thing I want to do is I want to rename some of the columns. So I'll say df dot rename. I'll say columns equal to, now we are going to pass in a dictionary. I'm going to change the rank to test underscore lap underscore rank. Let me give a comma. Now I'll say name underscore x equal to, I'll say the Grand Prix name. So I'll say GP underscore name. Next column I'm going to focus is the nationality column. So I'll say nationality underscore x. I'll give a colon. The value I'm going to pass in is driver nationality. Alright. Up next we have one column called underscore y, and that I'm going to change it to constructor name. Another comma, I'm going to say nationality underscore y colon, change it to constructor nationality underscore nationality. Finally we have driver underscore ref column, and that I'm going to replace with just driver. Finally I'll say in place equal to true. Cool. Just verify if all the column names are correct. Let's run it. Alright, so now we have successfully renamed the columns. After that, in the next cell I'm going to rearrange the columns. So here I'm using the same data frame and we have just renamed the columns. So starting with year, Grand Prix name, round, driver, nationality and others. Let's run this. Up next we're going to drop the 2019 season data because it is incomplete. So I'll say df equal to df, then I'll say year not equal to 2019. Let's see how to sort the values. So I'll say df equal to df dot sort underscore values, which is the function name. I'm going to sort it by year, followed by round, followed by the position underscore order, comma, I'll say ascending equal to first, let's say, is false, next I have true, and then I'll have true. Alright, moving ahead, now we are going to see how to replace the /n values in the time column with something called NaN, because the time column was not registered when a driver did not finish a race or was lapped by another driver. So to do this, I'm going to say df dot time dot, I'm going to use the replace function, and here I'll say forward slash or backward slash n, and I'm going to replace with numpy's NaN. I'll say in place equal to true. Let me just copy this because we are going to use the same meters. Next, I'm going to replace the milliseconds value, the milliseconds dot replace. I'll paste it here. Then I'll say df dot fastest underscore lap underscore rank dot replace. Paste it. Next I have df dot fastest dot lap dot time, they replace. To that I have the next column, which is speed. So I'll say fastest underscore lap underscore speed dot replace. I'll paste it. So here I'm going to replace this particular value, the backward /n, with NaN. Let me run it. Cool. Step, I'm going to change the data types for fastest underscore lap underscore speed to float, then fastest underscore lap underscore rank to float again. Now problem here is we cannot convert it into an integer because there are missing values, so we are going to change it to float. Again, for milliseconds also we are changing it to float values. Let me run it. Now I'll reset the index. Let me show you how to reset the index. I'll say df dot reset underscore index. I'll say drop equal to true. I'll give a comma and say in place equal to true. All right, that we have done our initial processing step of the data set. Now we'll check the shape of the data set. Then we see all the data sets, the total number of non-null values, the memory usage, and we'll check the head of the data set. Now to see the total number of rows and columns, I'll say print df.shape. You can see here there are total 24,197 rows in my dataset, and there are total of 15 columns. Now let's use df.info function. So it gives me the year, the Grand Prix name, the round number, driver, constructor name, grid, position order, total number of points, time, then time in milliseconds, the fastest lap rank, the fastest lap speed, the nationality of the driver, the nationality of the constructor. Then here we have the total number of non-null objects. And then you also have the memory usage at the bottom. Finally, let's see the head of the data frame. So I'll say df.head. Let's say I want to check the first 10 rows. There you go. If I scroll down, you can see here we have the top 10 rows printed, and you have the year, the Grand Prix name, round, driver, constructor name, and other columns. Now let me just brief you about what these column names stand for. So the year column that you see here is the season that the Grand Prix took place, and then we have the name of the Grand Prix. Now the round column is the number of the race in each season. For example, 1 means it was the first race of the season, and then 2 means it was the second race of the season, so on and so forth. Then we have the name of the driver. For that we have the name of the car constructor, so you can see Ferrari, Mercedes, Red Bull, Renault. Then we have the grid, that is the starting position before the race. Actually, this depends on the qualifications which occur 1 day before the race. Then we have the position underscore order column. This means the final position at the end of the race. Then we have the points column, that is the total number of points scored in the race. Next we have the time, that is the amount of time that took to finish the race. Only the winner's time is displayed, and drivers behind the winner are shown how far behind the winner they are. Then we have the milliseconds column, that is the amount of time that took to finish the race in milliseconds. If I just scroll down, I'll just move to the right, go to the top. Then we have the fastest underscore lap underscore rank, that is the order of the fastest lap during a race. Next we have fastest lap time, that is the shortest amount of time that took to complete a lap in the race. Then we have the lap speed, that is the average speed of the fastest lap. Then we have the country to which the driver belongs to, and then we have the constructor nationality, that is the country where the car constructor is based out of. Okay. Now here I'm going to set my figure size to 10,6. This is going to be for all the plots that we are going to create afterwards. Cool. We'll create a data frame that will have all the Grand Prix winners. So here I'm going to say driver underscore winner equal to, use my data frame df dot, I'll say loc, then I'll say df, I want the position underscore order, and that should be equal to 1, so which means the driver won the race. And then I'm going to use the group by function. I'm going to group it by driver, and for values I'll say position underscore order, use the count function followed by sort underscore values. I'll say ascending equal to false. Change it to 2 underscore frame dot reset underscore index. So what essentially I am doing here is I am finding out all the drivers that have participated and won a Grand Prix. Next, I'm going to create a bar plot. So this is going to be the first visualization of our analysis. So I'll say SB, which we have taken in our analysis. Ideally it should be SNS, but SB also will work. So I'll say SB dot bar plot. I'm going to say data equal to driver underscore winner. In the y-axis, I'll have driver. In the x-axis, I'll have position underscore order. Then I have color equal to green. That I'll set my alpha value to 0.5, or let's say 0.8. Then we are going to give a title to our plot. So I'll say plt dot title. Let's say most Grand Prix winners in F1. Then we are going to label our axis. So for y label, I'll have driver name. We have the x label that will have number of Grand Prix wins, and I'll say plt dot y ticks. Cool. Let's run it, and you can see we have our first bar plot here. Now the bar plot shows that there are a large distribution of Grand Prix wins. Only a few drivers in history of F1 have won over 20 Grand Prix in their careers, and there are some drivers who completely dominated the F1 racing and have won over 50 Grand Prix in their careers. So we are going to focus on those top 5 or top 10 drivers in the next section. So what I am doing here is, from the above result that we just got, I'm going to filter out only the top 10. So I'm going to use the head function, and inside that I passed in 10. If I print it, you can see here, as per the data that we have Michael Schumacher, who is the position order leader with 91 GP wins. Then we have Hamilton, Vettel, Prost, Senna, Alonso. Then we have Stewart, Clark, and Lauda. The data that we have is not the most recent one. So if you check the actual stats, Hamilton has actually overtaken Michael Schumacher and has won over 103, close to 103 races as of now. And next we have Michael Schumacher. So this is not the most recent data. Cool. Now using this data, we'll create another bar plot for the top 10 drivers. So I'll say SB dot bar plot. I'll say data equal to the name that we have used, that is top 10 drivers. So I'll say top 10 drivers. In the y-axis, we'll have the driver name. In the x-axis, we'll have position underscore order. For the bars, I'm going to use a color equal to, let's say, blue this time. I'll set my alpha value to be 0.8, and I'll say, let's say, line width equal to 0.8, and I'll also give an edge color of, let's say, black. Cool. Follow the same drill. I'm going to give a title to my plot, so I'll say plt dot title most GP winners in F1. I'll give a Y label that says driver name, and then I'll have X label which will have number of on prey wins. Cool. Let me see if everything is fine, and then we'll run this. There you go. You can see we have a very nice horizontal bar plot that shows the top drivers in F1. So as per our data that we have Michael Schumacher, who has won over 91 or close to 91 races. Then we have Hamilton, Vettel, Alonso, Clark, and others. All right. In the same way, we are going to create bar plot for the top constructors that have participated in F1. So here I'm finding out all the constructor winners. So here I'm using my position underscore order equal to 1, and then I'm using the group by based on the constructor name, and then I'm finding the count of position order and sorting the values in descending order, and I'm changing it to frame or to a data frame. And to create my bar plot, I'm using the bar plot function, the data which is constructor underscore winner. In the y-axis I'll have the constructor name, on the x-axis I'll have the position order. So you can see here I've used color as pink, and I've given a title, x label, y label, and y ticks. Let's run it. There you go. So here you can see again the data is widely spread. So we have a lot of constructor names. Now our next task is to check the top 10 GPA constructor winners. So here I'm using the head function and finding out the top 10. If I run it, you can see here the manufacturing companies or the constructors who have won the most number of races are Ferrari, McLaren, Williams, then we have Mercedes, Red Bull, Team Lotus, Renault, and others. Okay, now we'll convert this data into a horizontal bar graph or a bar chart. So that will show the bar plot for the top 10 constructors. Now let me show you how to do it. So I'll say SB, which is for Cbond dot bar plot, going to say data equal to top 10. Let me just confirm the name. We have top 10 constructors. Scroll down, I'll say constructors. The y-axis I'll have constructor on the x-axis I'll have position underscore order. Then I'll say color equal to, let's say we'll use the red color for the bars. Then I'll set my alpha to 0.8. I'll say line width equal to 0.8, and my edge color I'll say black. That I'll say plt dot title, say top 10 most GP wins lt dot y label would be constructor name, then I'll have plt dot x label as number of GP wins. Cool. Let's run it. There you go. So here you can see we have Ferrari at the top, then we have McLaren, Williams, Mercedes. I'm pretty certain by the end of 2021 season, Mercedes would have gained a lot of wins since Hamilton has been on the top for Mercedes for quite some time now. All right. Now, finally, we are going to create a regression plot that will show how two variables, that is the starting position and finishing position, vary. So to do that, I'm going to exclude the data points with grid 0 because it skews the data. So 0 means that the driver started from the pit lane. So I'm using this function called reg plot to plot my regression line. Let me run it and show you the result. There you go. So if you see here, we can easily see there's a linear relationship between the starting and finishing position. So on the x-axis we have the starting position, on the y-axis we have the finishing or the finished place, so which is what is actually expected, right? Now we can also see that most races had up to 25 drivers. You can see the density of the points here, but some of the races also had over 30 drivers. You can see the light color blue dots. Next, we are going to check whether the speed of the cars changed over the years. Now, since this data is only available from 2004 onwards, so we have taken years that start from 2004 onwards. Now let me show you the result of this data. So essentially we are plotting the average speed amongst all teams during the fastest lap at individual Grand Prix, and here on the y-axis you have the average fastest speed in kilometer per hour, and then you have the different GPs, and you can see here the year values. Now in general what we see is there's a decrease in the average fastest lap from 2004 till around 2015 for almost all the circuits, and again from 2015 onward the speed started to increase. You can see here there's an increase after 2015, there's an increase here as well. You can also notice that the speed is very different on each track. For instance, if you check the Italian Grand Prix, which is here, Italian GP has the fastest race in the calendar with average speed exceeding over 240 kilometers per hour. On the other hand, if you talk about the Monaco Grand Prix, let me show you. If you see here, the Monaco GP is the slowest race with average speed below 160 kilometers per hour. Now this is actually expected because the Monaco Grand Prix has very narrow streets and hence the drivers cannot drive fast in this circuit. All right, so now we are going to look at healthcare market forecast. So as per marketsandmarkets.com, the healthcare analytics market is projected to reach 75.1 billion US dollars by 2026 from 21.1 billion US dollars in 2021. Now talking about India, as per statista.com, India's healthcare sector was about 160 billion US dollars in 2017. It was estimated to reach up to 372 billion US dollars by 2022. Now, as per RBC Capital Markets, approximately 30% of the world's data is generated by the healthcare industry. By 2025, the compound annual growth rate of data in healthcare will reach 36%. Now, that is 6% faster than manufacturing, 10% faster than financial services, and 11% faster than media and entertainment. Now, let's see the various applications and issues that analytics can solve in healthcare. We will look at drug discovery, staffing and operation, and see how analytics can help predict diseases. So, talking about drug discovery. Now, the drug discovery is a very long process. Sometimes it takes about 12 years and costs way too much, about 2.6 billion US dollars. Now, data analytics can increase the drug delivery process rate in medical science, helping to gain faster approval from the Food and Drug Administration. It can help optimize and improve the efficiency of clinical trials. Another key development that has happened in a number of pharmaceutical companies like AstraZeneca, Bayer, Clenzine, and Janssen Research and Development has recently announced a data sharing initiative called Project DataSphere. These companies have agreed to share historical cancer research data to help researchers in the fight against the disease today. The database will be available online globally, and the analytics technology would be provided by software vendor SAS. Now, moving on, we have staffing and operation. Now, this is another crucial problem that every staff manager in a hospital faces, that is, the problem of staff allocations at a given period. Understanding how many people a manager should put on a staff at any given time period can be very challenging. If you put too many workers, the risk of having unnecessary labor costs go up. Too few workers, you can have poor customer service outcomes, which can be fatal for patients. So business analysts can use data to forecast patient admission trends at specific times of the day and provide insights to the staff managers to assign the right number of staff during peak and slow periods. Next, we'll talk about predicting diseases. So business analytics can also predict trends in the spread of illness, allowing doctors, hospitals, medical staff, and individuals to adequately prepare themselves. For example, in the case of coronavirus, analyzing data to predict future spikes in cases can help hospitals ensure the staff have enough protective equipment and patient beds. Using medical imaging and algorithms, physicians can detect diabetic retinopathy, which is a condition that damages the eye due to diabetes, and algorithms can also help detect cancer cells in a patient. Detecting cancer at an early stage has been a focus area in healthcare for quite some time now. The Cancer Moonshot Initiative by former US President Barack Obama, initiated in his second term, relies on advanced analytical techniques to pace up the discovery of cancer cures by identifying the trends and treatments used worldwide that have the highest success rate. Now, let's look at the hand washing case study in detail. So, to give you some context, before the mid-19th century, the science of bacteria was not discovered yet. Nobody knew that microorganisms could spread diseases. Back then, even hospital staff did not follow basic hygiene practices. Not even doctors cared to wash their hands. Now, to be honest, we all realized the importance of hand washing after the world was hit by coronavirus pandemic. Now, meet Dr. Ignaz Semmelweis. He was a Hungarian-born doctor and practiced at the Vienna General Hospital's maternity clinic between 1846 and 1849. Dr. Semmelweis is regarded as the father of infection control for discovering the medical benefits of hand washing. Dr. Semmelweis was very disturbed by the increasing fatality rate of mothers from childbed fever at Vienna Hospital. So childbed fever is also known as puerperal fever. It happens due to infections in the female reproductive tract following childbirth. This child fever was an issue of concern throughout Europe, with some hospitals having over 40% mortality rate. So out of every 100 mothers who used to give birth, at least 40 mothers would die in a week or 2 weeks' time. So the demo case study I'm going to present now concerns the work of Dr. Ignaz Semmelweis in reducing the risk of childbed fever during childbirth in Vienna Hospital during the mid-19th century. So he collected and analyzed historical data on deaths in his clinic and established a theory of what was contributing to increasing deaths of mothers. Now, to solve a problem, business analysts would often need to collect data from multiple sources. For this demo, we'll be using 3 datasets that are publicly accessible on Kaggle and GitHub. Let me go ahead and show you the 3 datasets first.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, so this is the first dataset that I have, which is called the yearly fever mortality dataset. So here you can see the first column is about year. It starts from 1784 and it goes till 1846. The next column we have is about the total number of births that took place at the Vienna General Hospital maternity clinic, and then we have the total number of deaths reported from childbed fever. Next, then we have the fever mortality per clinic. So in the Vienna hospital, there were 2 separate clinics that operated between 1833 and 1846. Birth 1 column represents the total number of births that took place in clinic 1. Similarly, deaths 1 column represents the total number of deaths that took place in clinic 1 of the maternity clinic at Vienna General Hospital. Births 2 and deaths 2 has the information about the births and deaths that happened in clinic 2. Then we have our final dataset. This dataset is about monthly deaths, which starts from January 1841 till March 1849. We have the total number of births and the total number of deaths, and this monthly underscore deaths is only for clinic 1. We'll learn in detail about clinic 1 and clinic 2 at the maternity hospital and what they represent in detail. All right. Okay, so this is my Jupyter notebook, which has the lines of code already written. I'm going to explain you each cell of code and we'll explore the hand washing case study by looking at the outputs for each of the cells. Let's start with the first cell. So here I'm going to import my first data set, which is the yearly fever mortality. This is a CSV dataset, and to load the dataset, I'm using the pandas library and the read underscore CSV function. I'm using parse underscore dates equal to year. So this parse underscore dates will format the year column in the form of a date value. Next, I have set my index to be the year column. You can see here set underscore index equal to year, and I am mentioning that in place equal to true, which means that the original data is now modified and updated in place. And I'm importing the data and storing it in a variable called yearly underscore deaths. Next, I'm going to print my data set. Let me just hit Shift Enter. We can see the result. There is an error here. It says, okay, this should be yearly underscore deaths. Let me run it again. There you go. So here you can see we have set the year column as our index. You can see the year column is our index. Then we have the other 2 columns, the total number of births and the total number of deaths starting from 1784 till 1846. All right. Now you can see the values for year, total births, and the total number of deaths from 1784 till 1846 in the maternity clinic of Vienna Hospital where Semmelweis used to practice. Coming to the next cell of code, here we are going to calculate the mortality rate or the mortality percentage. For that, I'm going to create a new column called as mortality. So here I'm mentioning my data frame, which is yearly underscore deaths that we created above. And then within square brackets, I'm passing in my new column name, which is mortality. And the formula to calculate mortality is total deaths divided by the total number of births into 100. Now let's print the result. You can see here we have added a new column called mortality, and it has given us the mortality rate for each of the years starting from 1784 till 1846. Now next we are going to find out some descriptive statistics using the describe function. So I've used yearly underscore deaths dot describe. If I run it, you can see the count, that is the total number of rows that are there in our dataset. Then we have the mean birth. So the average birth that has taken place in all these years per year is around 2268. The total deaths reported in each of the years, that is the average number of deaths, is around 93, and the mortality is around 3% or 3.3%. We have the standard deviation, we have the minimum value, that is the least births that took place in one of the years was 284 and the maximum is 4010. Then we have the 25th percentile, the 50th percentile, and the 75th percentile. We are going to create our first plot, that is plot about yearly mortality rate each year between 1784 till 1846. Now here we are going to create a line plot, and for that I'm going to import my matplotlib.pyplot as plt. I'm setting my figure size to be 14,5, and using the plot function I'm going to create my line plot. I've given my data value as mortality rate. I'm going to use color as green and marker as O. So O will represent as dots. And after that, I'm going to give a title as mortality from childbed fever during childbirth. I've given a X label as year and Y label as mortality rate. Let's run and see the output. There you go. If I scroll down, you can see here we have a nice line chart. Now we can notice that the mortality rate started increasing somewhere around 1823. From here you can see a spike, and gradually the mortality rate or fatality rate from childbed fever started increasing from around 1823. The reason was, you can see here, there was a sharp increase after 1823. So the reason was, around 1823, Semmelweis Clinic started giving lessons on pathological anatomy. So pathology, I guess you would know, is the branch of medicine that deals with the study of causes and effects of diseases. So doctors would take classes on the corpse's organs and tissues to learn the reasons for the cause of the death. So after the postmortems, then they might deliver a baby or examine a patient, possibly with pieces of contaminated flesh remaining in their hands. So Semmelweis suspected that this could be the reason for childbed fever. So he continued with his analysis and looked for further evidence to support his hypothesis. Now till 1832, there was only one maternity clinic at the Vienna hospital. Now that had become very overcrowded, so an extension was built and two clinics were created in 1833. 1833. You can see it here. Now, until 1840, both clinics were used for teaching and training medical students and midwives. So midwives are people who help mothers deliver babies and take care of newborns after childbirth. So after 1840, the physicians, that included doctors and medical students, used to operate in Clinic 1, and only midwives used to operate in Clinic 2 after 1840. So Semmelweis spotted that in Clinic 1, the fatality rate for mothers from childbed fever was 3 times more than those who delivered in Clinic 2. So you can see here in Clinic 1, which was the doctor's ward, and for people who were given trainings, the mortality rate was 10%, while in Clinic 2, where only the midwives operated, the mortality rate was 3%. So he again believed that in Clinic 1, where doctors and physicians operated, they also used to handle corpses during autopsies before operating on pregnant women. And they never used to wash their hands between the two jobs. But midwives in Clinic 2 never went to the autopsy room. So Semmelweis spotted that there were links between the lack of hygiene of the doctors and the mortality rate of the mothers. So let's analyze that data now. Cool. So I'm going to import my second data set, which has the information about births and deaths in Clinic 1 and Clinic 2. So here I'm importing my CSV data set and I'm storing it in a data frame name called clinics. Again, I've used parse_dates as year to format the date values. I've given my file location followed by the file name and dot the extension of the file, which is CSV file. Again, I've set my index to be the year column and I'm printing the head of the data frame now. Let me hit Shift Enter. Okay, so here you can see 1833 onwards, birth 1, death 1, that is for Clinic 1. Then we have births 2, deaths 2 for Clinic 2. Next, we are going to calculate the mortality for both the clinics, that is Clinic 1 and Clinic 2. So what I'm doing here is I'm creating two columns, mortality 1 and mortality 2. So mortality 1 is for Clinic 1, then mortality 2 is for Clinic 2. Again, the formula is the same. Deaths divided by births into 100 is the mortality rate. Let me run it. And now we are going to see the first 10 rows from our newly created data frame. You can see here we have added two more columns, mortality 1 and mortality 2. And these are the results. Now, if you notice, you see the mortality rate for the Clinic 1, where Dr. Semmelweis used to practice, or the physicians who also operated on the dead bodies used to practice. So the mortality rate is high there. Now let's compare and visualize the mortality rate at both the clinics. So here I'm again setting my figure size to be 14,5. I've used clinics.index mortality 1. I've given a label as Clinic 1. Color I'm using as teal, marker is O. So this O will make sure for each of the years we have a dot or a round shape. Similarly for Clinic 2 we have mortality 2. I'm using blue color, again marker as O. Then I'm giving a legend, a title called mortality from childbed fever during childbirth. I also have a Y label called mortality rate. Let's run it. Now if I scroll down, you can see the mortality rate from 1833 onwards till 1846 for both the clinics. The teal color represents Clinic 1 and the blue color represents Clinic 2. So from this graph, we can see that the death rate at Clinic 1 was significantly higher after 1840. You can see there is a huge spike compared to Clinic 2, where only the midwives practiced and they never operated on the dead bodies in the autopsy room. So now Dr. Semmelweis had strong evidence to believe that the doctors were transmitting infectious flesh or you can say material, substances from previous operations to mothers through their hands, and this was leading to childbed fever. So far, we have seen in our analysis till 1846, Dr. Semmelweis in mid 1847 asked his colleagues and fellow physicians at Maternity Clinic 1 to wash their hands with chlorinated lime solution before attending pregnant mothers, and the results were significant. So let's see the final analysis of Clinic 1 where Dr. Semmelweis practiced and how he was able to reduce the mortality rate. Now I'm going to load the monthly deaths dataset that has information from January 1841 till March 1849, and after 1849 his contract was terminated and he was asked to leave the Vienna hospital. I'll tell you why he was asked to leave a little later. Let's load the final dataset now. Okay, so I'm going to import my final dataset, which is the monthly underscore deaths.csv. I'm storing it in a variable called monthly underscore data. Let me run it. So here you can see the data for all the months starting from January 1841 till March 1849. Next, I'm going to find the monthly mortality at Clinic 1. So I'm going to divide the deaths divided by births into 100. So here you can see we have created a new column called proportional underscore deaths that has the death rate for each of the months. Now the doctors in Clinic 1 started washing their hands in June 1847 before carrying out delivery operations. So we have divided the original data into two data frames called before washing and then we have after washing. We will set the start of hand washing date to 1st of June 1847. You can see here I have said start of hand washing pandas dot to data frame. I'm giving my hand washing start date, that is 1st of June 1847. For washing data frame will have all the values that lie prior to June 1847. So here I have subset my data. I'm saying date should be less than our date, which is 1st of June 1847, and after washing should be greater than equal to 1st of June 1847. Run this. I'll print my before washing data frame. You can see it has taken all the values till May 1847, and for after washing we have all the values starting from June 1847 till we have March 1849. So we have split months data into before and after hand washing start date. Now let's plot our final graph that shows the difference in the mortality rate of mothers before and after hand washing. So here I'm setting AX, which is the axis for before washing. Dot plot will create a line plot. I'm saying X to be date, Y to be proportional deaths. I'm giving my label to be before hand washing. I'm using color as C, which is for cyan. Then here B represents blue. This is for after hand washing. Again, X should be date, Y should be proportional underscore deaths. Here I'm using a line style to be dotted lines to just compare the plots. I've set my Y label to be proportion deaths. Let's run it and you can see the result. Let me scroll down. There you go. On the x-axis we have the date, on the y-axis we have the proportion deaths. The cyan color represents before hand washing, that is the solid line, and we have the dotted lines for after hand washing. Now you can see how starting from the summer of 1847 the proportion of deaths got reduced significantly, less than 5%, you can see here. So this was when Semmelweis made hand washing mandatory. Now we'll calculate the difference in average monthly percentage deaths before and after hand washing. So what I'm doing is I'm creating two variables, before proportion and after proportion. And then we are going to subtract the before proportion mean minus the after proportion mean. If you see the difference, you can see here it is 8.3%. So from 10%, we just reduced it to less than 3%. So this was all about the hand washing case study that Simplilearn had conducted using different data sets. So we performed this exploratory data analysis using 3 data sets, and we explored how using pandas and matplotlib you can create different charts and analyze data, yearly data or time series data. Now, the sad part is that with all this exploratory analysis and the findings Dr. Simplilearn made, his superiors at Vienna Hospital refused to accept his theory, and he was met with a lot of criticism. Medical community rejected his discovery in March 1849, and he was forced to leave the Vienna General Hospital. One reason we can argue as business analysts is that statistical analysis and data visualization were very uncommon those days in the field of medical science. Simplilearn only published his data as long tables of raw data, but he couldn't show any graphs or confidence intervals to support his hypothesis. His ideas were considered as offense to the medical community. He hurt them since Simplilearn meant that doctors were the cause of increased deaths. He believed in another theory called miasmus, which basically means some bad component in the air was the cause of childbed fever deaths. After 2 decades, when Joseph Lister and Louis Pasteur produced more evidence of the germ theory and antiseptic techniques, only then the value of hand washing was appreciated. But nevertheless, his work was based on evidence supported by numbers, showing that simple hand washing by healthcare workers could save millions of lives. Later, he did get some recognition. The Budapest University, where Dr. Ignaz Semmelweis used to teach after getting terminated from Vienna General Hospital, is now named as Semmelweis University. In January 2019, the statue of Dr. Semmelweis was unveiled at the World Health Organization by the current Director General, Mr. Tedros. You can see on the right. On the left, we have the State Secretary of the Ministry of Foreign Affairs and Trade from Hungary. On the 100th anniversary of his death, the government of Austria issued a postage stamp in his honor. And in March 2020, after the world was hit by coronavirus, Google also recognized Semmelweis' hand-washing findings and gave him a Google Doodle. And that brings us to the end of our interesting video tutorial on Dr. Semmelweis' hand-washing case study using Python. I hope it was useful and informative. If you have any queries, please feel free to put them in the comment section of the video. Thank you for watching. Stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.